This presentation was done by Ariana Crossman,
Isabel House, and Gabriella Moonshine.
It is on the multiple resource theory, specifically addressing dual task interference.
For our content for the presentation, we will go over the background, which includes our introduction and hypothesis. We'll go on to discuss the methods for our design and then procedure of methods. After that, we will talk about the result and show visuals for our result in the results table section. We will then talk about our discussion and go over our appendix. For our background, our hypothesis is when two tasks have overlapping modes or codes, they will have more interference and therefore less correct answers to our measurable task questions. An auditory verbal interference task will have a larger negative effect on correct answers than a visual spatial task. In our introduction, we talk about how multitasking can overload our limited cognitive resources, especially when tasks have similar demands. Multiple resource theory, or MRT, explains that tasks have overlapping cognitive resources, like visual or auditory modes, interfere more with each other. Our study tests this by examining how different tasks pairings affect performance, particularly in mathematical problem solving, combined with either auditory verbal or visual spatial tasks. We hypothesize that the task requiring different resources will cause less interference and yield better performances. This aligns with MRT's suggestion that separating cognitive resources improves multitasking efficiency.
We had a counterbalance within subjects design. As looking at the Latin square above, it represents our 2x4 design, in which we separated the participants into two separate groups. The A test was our audio-verbal, and the B test was our visual-spatial. Group 1 did audio-verbal first and visual-spatial second, and Group 2 did the opposite. Participants were randomly assigned into one of two testing groups depending on the order in which they entered the room. Each testing round featured a different order of set of math problems, with randomized problem sheets for each round, 5 rounds in total, including the control. Our tests were auditory verbal, in which we did tongue twisters. Participants would recite the tongue twister aloud while also solving math problems. Tongue twisters they were provided with were Sally sold seashells by the seashore and the big black bug by the big black bear. The second test was our visual spatial test, in which it was the ball toss. Participants would pass the ball back and forth as they solved math problems at the same time. Our independent variables were the different dual task conditions, audio, verbal, and visual spatial. Our dependent variables was the number of math problems answered correctly in each condition. Each participant completed a control task and then completed the dual tasks twice. Each individual test was timed for 30 seconds, and then the final number of answered math problems for the test was recorded to measure the child's performance.
We analyzed our results, and we got a mean score for the auditory verbal task of 8.13 math questions answered correctly, and a mean of 12.13 math questions answered correctly for the visual spatial task. As you can see on the graph to the right, it is a very significant difference. The main results were analyzed as a paired samples t-test to compare the differences between the average number of math questions of the auditory verbal and visual spatial tasks. After gathering data, a t-test showed that there was significant difference in the scores for auditory verbal and visual spatial, as you can see on the first line of the second table. These results support the hypothesis and suggest that interference that comes from dual tasking with two tasks of the same mode and code significantly impact the performance of at least one of the said tasks. There are still plenty of further applications to this research, including applications on how engineers design interfaces such as internal automotive interfaces to reduce the amount of cognitive interference overall for the driver.
For our appendix, we have what we recorded in our Google form. We asked them what their age was, and we also asked them what the gender they identified with. We picked the condition that they would be in, and then we randomly assigned the order of math sheets. From there, we put down the answer of how many math problems they answered correctly during the control trial, and then we went with which tongue twister did they use. From there, we answered the questions of how many questions did they answer correctly in the auditory verbal and visual spatial trials 1 and 2.
Thank you.